Hi and welcome to a bit of linear graphs revision. These questions we'll have here, they're all going to have the same question: state the gradient, x-intercept and y-intercept for each of the equations, and then sketch the graph for the domain between -2 and 3. So this first one here, firstly for the gradient, m, get this pen working, m is equal to, it's the coefficient of x. So in this case, the gradient is just equal to 2, which if you wanted to write that as a rise over run will be 2 over 1. For the y-intercept, then that's the last bit there, plus 3. Now, if you had to calculate that for the y-intercept, what you do is go through a little calculation where we say that for the y-intercept, we make x equal to 0, and then we just work through the equation. So we have y is equal to 2 times, but x is equal to 0, so 2 times 0 plus 3. 2 times 0 is just 0, which gives you y is equal to 3. So if your y-intercept, that's plus 3, or if we write that in coordinate form, it would be x is 0 and y is 3. Similarly, for the x-intercept, we go through the same process. So for the x-intercept, we make y equal to 0. Substitute that into the equation, so we'll have 0 is equal to 2x plus 3. We need to get x on its own or solve that for x. So we look at what's joined on. This is 2 times x, and then it's plus 3. BODMAS backwards is what we apply. So plus 3 is the least strongly attached, if you like. So we'll move that first. We go take away 3 from both sides, which gives us -3 equals 2x. And then we're going to divide both sides by 2 to cancel that one down, which will leave us with x is equal to -3 over 2. So that'll give us an x-intercept of -3 over 2, or in coordinate form, it'll be equal to -3 over 2 and 0. And then the next part of this is it wants us to sketch the graphs. Let's see if I can squish this up a little bit. Oh, I've spun around too. Look at that. So that now gives me a bit of room for a quick sketch graph, like so. X will be -3 over 2 for the intercept. So if we make that in there, the y-intercept is 3, so it's up here somewhere. And then we have to sketch the graph. I can't put a ruler onto this for some reason, because it makes marks everywhere, that's the reason. So always good to use rulers where you can, but if you're doing a quick sketch, the key things is that you need to identify the intercepts, 0 and 3, label everything that you can, and another one is -3, 2 and 0. So that's the sketch graph for that one. Let's move on to the next question. Now we've got to apply the domain here, so square brackets means it's inclusive. I'm going to put a solid end at both ends. That should actually go up a bit further there. A nice solid end. Now, for the restriction that we have for the x-coordinate, that's going to be -2, and we need to work out the corresponding y-coordinate for that. So we just substitute x equals -2 into the equation. So y equals 2 by -2 plus 3, which equals -4 plus 3, which equals -1. So that will be -2 and -1 for that point there. And for the other end, up the top, the x-coordinate will be 3. And to find our corresponding y-coordinate, y will be 2 times 3 plus 3 equals 6 plus 3, which is 9. So we get 9 as our coordinate there. Okay. gradient, x-intercept and y-intercept for the following. So I'll start off by finding the intercepts. So for the x-intercept, we make y equal to 0. So from the equation, 3x plus 4y equals 12. Now, y is equal to 0, so I can just cancel that down because 4 times 0 will just be 0, which leaves us with 3x equals 12. Then divide both sides by 3, which gives us one lot of x will be equal to 4. And for the y-intercept, it's the same process. X equals 0. So we have 3x plus 4y equals 12. X is equal to 0, so that bit cancels down, leaves us with 4y equals 12. We'll divide both sides by 4. Gives us y is equal to 12 divided by 4 is 3. Okay. Sketch graph that we have for this one, we can do that now. X is 4 and y is 3, so it'll be a graph that looks a bit like that. So we have an intercept of x equals 4, or that's 4 and 0, and y is equal to 3, so that one will be 0 and 3. Y-axis, and label the x-axis. And then for the gradient with this one, the two ways that you could have done it was one, you could rearrange the equation. And I'll show you, I'll just go through that process to put it into the form of y equals mx plus 3. So if we have 3x plus 4y equals 12, we'll take away 3x from both sides, which will leave us with 4y equals negative 3x plus 12. And then we'll divide everything by 4. You have to divide the 3 by 4 and the 12 by 4, which will give us y is equal to negative 3/4 of x plus 12 over 4 is 3. So in this case, the gradient, m, is equal to negative 3 over 4. The other way you could have done it if you sketch the graph first is you can identify the rise over run. So it goes down 3 and it has a run of 4. So m would be equal to rise over run, which is negative 3 over 4. Doesn't matter which way you do it, but in both cases you get the same answer for the gradient. Next question. Now, applying the domain for this one, possibly a little bit ahead of myself when I sketched the graph before, because we have a restriction between negative 2 and 3. So the restriction for the graph will be between negative 2 and x is equal to 3, which is before we get to that intercept. So the intercept doesn't actually exist. What the graph should have looked like is, it's a square bracket, so it's inclusive. We'll have a solid circle there, solid dot at the other end as well. And we'll find the coordinates, what that graph is supposed to look like. And when we have, oops, that needs to be a round bracket for the coordinates. When we have x is negative 2, then the y coordinate is going to be, we'll just have to do a little calculation there, so we get 3x plus 4y equals 12. When x is negative 2, we've got 3 times negative 2 is negative 6 plus 4y equals 12. Add 6 to both sides gives us 4y is equal to 18. And divide both sides by 4, we get y is equal to 18 over 4, which is 9 over 2 as a fraction, like so. And then similarly, we'll need to do another calculation for when x is equal to 3. So that was for x equals 4. For x equals 3, 3 times 3 is 9 plus 4y equals 12. Take away 9 from both sides will give us 4y is equal to 3. That will give us y. Divide both sides by 4, y is 3 over 4. So the coordinates for this point here would be 3 and 3/4. Okay, so if you're doing that one with the sketch graph first, like I did before, you probably have a little dotted or faint line that you can just draw over, darken in later on. Okay, next question. Now for this graph, I'm just going to draw the graph again to start with, keeping in mind our domain. Y-axis, x-axis. The graph is just going to be a graph going through at -2 on the y-axis. So it's going to finish up here at 3, and we'll finish here at -2. So our endpoints that we have here will be -2 and -2, and at this point is going to be 3 and -2. Horizontal line. So in this case here, our x-intercept doesn't exist. Because this graph is parallel to the x-axis. For the y-intercept, it passes through at +2. I was drawing the graph right, but I've just drawn all these negatives everywhere. Passes through at +2 or 0 and 2. Okay, and for the gradient in this case here is 0, so gradient equals 0. Okay. So if you ever see an equation y is equal to something, it's going to be horizontal. Whatever that value is where it crosses the y-axis, and you just go from there. Okay, next one. State the gradient x-intercept and y-intercept for the following and sketch the graph. So again, I'll sketch the graph first. This is another one of these funny ones. Haha, very funny. X, y. This one crosses over at x is equal to -5. So that's going to be like so. And in this case here, the domain is a bit ridiculous because the domain is just equal to -5. All right. So again, with this one here, we have our x-intercept is -5, or it's equal to -5 and 0 if you're writing it in the coordinate form. For the y-intercept, that doesn't exist. And there goes the bell for recess. I'm going to go and find myself a coffee. And the gradient in this case here is infinite. Or you would also say that the gradient's undefined. That's probably the more correct one, because in this case here, the rise over run, the run is going to be 0, so it's going to be something divided by 0, which is just undefined. Okay, let's see what else we've got here. State the gradient x-intercept and y-intercept for the following and sketch the graph again. So what I might do with this one here is rearrange this equation to make it into a format that you might be more familiar with. First thing I'll do is expand the bracket, so we have y plus 3 equals 2 times x is 2x plus 2 times 5 is 10. And then if I take away 3 from both sides, we have y will be equal to 2x plus 7. That looks a bit more familiar. So we can have our y-intercept will be equal to the 7 plus 7 at the end there. The gradient will be equal to 2. And for our x-intercept, we need to make y equal to 0. So 0 will be equal to 2x plus 7. If we take away 7 from both sides, we get negative 7 is equal to 2x. Then divide by 2. That'll give us x is equal to negative 7 over 2. And we'll quickly sketch the graph and get away from all this background noise out the window. Hang on. So to sketch this graph, the x-intercept is negative 3 over 2, which is negative 7 over 2, which is negative 3.5, which would be here somewhere. And the y-intercept was plus 7, so our graph would go through something like that, where we have negative 3.5, and the scale's out a little bit here, but anyway, but that would go through at 7. But we have our restriction for the domain, so that tells us that we can only go as far as negative 2 there, and we can go as far as 3 over here. So our graph is going to go through like so. Closed end there, closed end there. So each of our endpoints, when x is equal to negative 2 for the first one, substitute negative 2 into our equation. So I'll just use y equals 2 by negative 2 plus 7 equals neg 4 plus 7, which equals 3. So that's negative 2 and 3. And for the other end, where x is equal to 3, we've got y is equal to 2 by 3 plus 7. 6 plus 7 equals 13. So up here we'll have 3, 13. And we have our y-intercept of 0 and 7. That's what our graph would look like, and I better label my x and y axes before I go. Hope you find that useful. See ya.